Hello, welcome back for another video. Look at that Zoom technology. Okay, what did the spy do before bed? He went undercover. Undercover. Okay. So today, this lesson, this video, if you're watching all of them in a row, good on you. But for this video, we're going to talk about, I guess, solving specific geometric problems to do with vectors. Okay, now here are a couple things that I think will be helpful, and then we'll tackle one slightly difficult question together and kind of see how it goes. Draw a diagram. This is non-negotiable. This is not a drill. Do it and don't ask any questions. Just draw a diagram and yeah, it will help in more ways than one. And then once you've drawn a diagram, they'll often start and give you points. So at that point, that's when you want to start introducing vectors. Okay. Also, a couple of things here. Remember that if you dot product two vectors and it equals to 0, we are given perpendicular lines. Parallel vectors can be written as scalars. So that means if we've kind of got like two parallel vectors, one can be written as a variant of the other. So it's kind of like terms. We can find angles using the dot product a dot b equals to magnitude a times magnitude b times cos theta. That's a helpful one. And then also here, just remember you can extend the diagram beyond what's given using a vector addition and subtraction. Kind of helps, especially to complete triangles or to complete trapeziums, parallelograms. That's the one. And also, don't forget in this topic here, we're going to be drawing from a lot of other different things. Just remember your basic geometry. Okay, so remember that a parallelogram is just, you need to prove that there's two pairs of parallel lines. For an area of a triangle, you've got half times base times height. Or if you're fancy, you've got half AB sine C. I believe we'll be using that one later. And rectangle is just the way that you prove that something's a rectangle is you say it's a parallelogram. So it's got two parallel lines, two pairs of parallel lines, and then you just prove that there is a right angle or there's perpendicularity. And then Pythagoras, you know that there's a squared plus b squared equals to c squared, blah, blah, blah. Okay, now my hint for this one here is this is probably where it gets the most difficult and they can ask you in a lot of different ways. So practice a variety of questions. Go through past papers, go to thsc.com, a whole bunch of past papers and look for the trial papers from 2020 onwards and look for the vector questions, okay? The more you see, the more you'll be prepared. Kind of logical, but you need to hear it, okay? So go put in the work. All right, let's tackle this big boy question, okay? Points A and B lie on a plane, so sure. So AB equals to 4, 1. That's the vector AB, right? 4, 1. And we also know that point C is chosen so that the area of triangle ABC is 17 on 2 units squared. And the length of AC is the square root of 34. And they want us to find all the possible vectors of AC. Okay, so first of all, I want to be a man of my word, draw a diagram. Okay, it doesn't have to be too fancy, but it just needs to be enough so that I can understand where things are and what's going on. Okay, now normally you would start at 0, but here it would probably make more sense for me to actually start at A because we know that AB is 4, 1. So that means I travel 4 across 1, 2, 3, 4, and I go up 1. Okay, 4, 1. And so I know that that's my vector B. Okay. Now here we know that AC has a length of root 34. So that means C, there's probably a couple different options and I'm going to dot these in just so you can start to see. I know that I'm making a triangle and I know that the area has to be 17 on 2 units squared. So there's probably going to be a C here. There's probably going to be a C in this quadrant here. There's probably going to be a C somewhere here in this quadrant. And there's probably going to be a C somewhere in this quadrant too. Now, I haven't drawn it great, but what I'm hoping for is I'm hoping that these will create, I guess, different triangles that will all have the same area. And I know that gets pretty confusing pretty quick, but that gives us a bit of an idea. Here we can see that we're probably likely going to see around 4 solutions. But from here, let's kind of put that on the back burner and try to work on it mathematically, algebraically, and see what we can get. Okay, first of all, they've told us that the area of the triangle is 17 on 2 units squared. Now, let's just the easiest way to do this is let's let C equal some unknown, and let's let it equal the vector xy. Okay, so it's kind of in relation to A. It'll go up an X, it'll go across an X amount of value, it'll go up Y amount of value. And we're kind of going to use this to help us to algebraically solve. Now, with this process here, we've got 2 that are complete unknowns. So we've got 2 unknowns, and so that tells me we're probably going to need 2 equations. Okay. So the first one here is I know that the length of AC should equal to root 34. So I'm going to write it as, well, I know that the square root of x squared plus y squared should equal to root 34. And so I can see here that x squared plus y squared should equal to 34. Okay, just by using the magnitude, right? So I was using the magnitude of AC, sorry. Okay, so that's one equation. Let's try to form the other one. The other one that I haven't used yet is the area. I said I'd do that first, but I saw the other one was a bit easier. So let's talk about the area now. Let's use the actual area of a triangle. And so what I'll need here is I'll need half AB sine C. So half AB sine C. Now, the reason that I need this is there's no guarantee that this is a right angle triangle. So I'm going to use this one for sure because I know I can find, here, let's write it this way. This is going to be 17 on 2 units squared. And I know that length A, I can call that, I guess, A, and I can call that length B, and that would be the angle in between. So let's try this. Half times the magnitude of A, and we know the magnitude of A we found before was, oh no, root 17. The reason that I got that is 4 squared plus 1 squared becomes the square root of 17. So that's just the magnitude of A times B, and we know that that's going to be the square root of 34 equals to, or times sine C, I forgot that, multiply by sine C, which is our angle, equals to 17 on 2. Okay, now let's continue going here. I can times 2 to both sides, and I'm going to rewrite some of these. Root 17 times 2, or root 2 root 17, sine theta equals to 17. 17 times 17 is, root 17 times root 17 is 17 root 2. Sine theta equals to 17. Sine theta will equal to, if I divide both sides by 17, that'll be 1. So sine theta will equal to 1 on root 2. Now this one's nice. I'll get either theta equals to pi on 4 or pi minus pi on 4. Now the reason that I'll need these two is because technically I'm going all the way around the circle. So that means I can either have pi on 4 or I can have 3 pi on 4. Okay, because it's the, if you've forgotten, it's the all stations to central. Sine is positive in the first 2 quadrants. Okay, so I've got theta equals pi on 4 here, and I've got also theta equals to 3 pi on 4. Okay, that's probably going to help me find some different solutions. Okay, now that I've got that, okay, I know this is feeling pretty heavy, but now what I need to do is I need to kind of relate the 2 vectors together. So I'm going to turn to this formula here. I know that A dot B, I know is going to equal to the magnitude of A times the magnitude of B times cos theta. Okay, now theta, we know the angle should be pi on 4 and 3 pi on 4. So let's kind of work at this bit by bit. Now the dot product of A and B, do we know yet? Let's just substitute in what we know. We know that root A, oh, sorry, not root A, but the magnitude of A is root 17. The magnitude of B was root 34. And we know that we have cos pi on 4. Or the other option would be cos 3 pi on 4. Okay. root 17, root 34. Okay, now A and B, we do have a vector for A. The vector for A is 4, 1. And the vector for B, we didn't know yet, so we're actually going to let equal xy. Okay, so if I was to rewrite this a little bit, let's try to clean it up. I'm going to scroll down. Apologies if you need to see it. If you need to, pause the question here to catch what's going on. Here's my first little bit of working out. Now I'm going to work from here onwards to try to get my second equation. I've got one equation up here, which is nice. And I'm trying to form my second equation right now. So now that I've got this, I'm going to do the dot product of A and B, which is in this case going to be 4x plus y. And that's going to equal to root 17 times root 2 root 17. And then it's going to be times cos pi on 4 is 1 on root 2. Or, and I'll write the or here this time, or it's going to be 4x plus y equals to root 17 times root 2 root 17 times negative 1 on root 2. The reason that this negative 1 is from this one, the cos 3 pi on 4. It's just 1 on root 2, but in the second quadrant. So cos in the second quadrant is negative. Yeah, by the way, if you're still sticking with me, well done. If you're not, pause the video, go back, watch it slowly, play it on like half speed, do whatever you need to. This is a heavy question. Okay. Now from here, let's clean up. This becomes 4x plus y equals 2. Now the root 2 will cancel out with the root 2. And the 17, root 17 times root 17 just becomes 17. There's one of my equations. And then the other one here is going to be very similar, but in this case here, I'll be left with negative 17. So 4x plus y equals to plus minus 17. Okay. We'll just minus 17 here. So I was jumping a bit ahead of myself. Okay, so let's take this one. And so 4x plus y equals to 17. I'm going to say, okay, y equals to 17 minus 4x. And then from here, I know the other equation I had was x squared plus y squared. I know had to equal to 34. So if I substitute it in, it'll be x squared plus 17 minus 4x squared equals to 34. Let's just go with it. It's going to be a wild time, but this would be x squared plus 17 squared. Man, this would be so much nicer if I had a proper calculator, which is 289. And then it should be minus 17 times 4 times 2. So this would be minus 136x. And then it should be plus 16x squared equals to 34. Now, just collecting like terms, this gives me 17x squared. And I'll do it in order here. I'll go, what's 289? 289 minus 34. That'll be 255. And then I'll have the minus 136x still. Okay, so I've moved the minus 34 over. I've minus the 34 over. That's my next line. I think this is nice enough where I can take out a common factor of 17. Yep, x squared minus 8 plus 15. Oof. Okay, now we can see if I'm just solving for x here, I can see that x would factorize to, it would be x minus 5, x minus 3 equals to 0. So x would equal to 5 or 3. Now going from this side here, I'll let you kind of go through the long way, but I know it gives you x equals to negative 5 and negative 3. And then once you find your x values, the way that you find your y is you can substitute it back into that one here. So 17, take away 4 times 5. That gives you minus 3. And then if it was 17, take away 4 times 3, which is 12, it'll be 5. So these are going to be these two. And then for these ones here, it'll be quite similar. But for these ones here, you plug it into y equals to negative 17 minus 4x, if I'm correct. So it'll be, if it's minus 5, it'll be 20, it'll be positive 3. And then this one here would be, I think, negative 5 plus 12. Yeah, negative 5. And so that will end up being your two sets of vectors. So therefore, AC, and which is wild, is going to be either 5, negative 3, 3 or 3, 5, negative 5, 3, and negative 3, 5. Okay, now if this question seemed difficult, it's because it kind of somewhat was. There was a lot of steps, and this one was what we would call an unstructured question. They don't give you part 1, part 2, part 3. They just boom, all in one go. And those questions are always going to feel a little bit more difficult. Okay, if I wanted to make this easier, what I'd say is, using, it's like draw a diagram, using the area of a triangle formula, find the value of the angle between, find the angle between AB and AC. And then from there, they would have broken it down to more questions, solve simultaneously for this, blah, blah, blah. But if you don't have it, you're going to have to piece it all together on your own. And yeah, just recognize that you're bringing in a lot of different formulas, but the main ones, the main players here are your dot product with the angle. And for this particular question, it was, where is it? It was this guy here, half AB sine C. Okay, so it's kind of like those are the main players, and then everything else kind of fit in between there. Okay, and the other hint was, let whatever you don't know be your vector xy, and then we can kind of solve for xy as we go. Okay, hopefully that was somewhat helpful. I apologize for this being a long and lengthy video, but these here would be your 4 different solutions, and I think those are the only 4. So looking at here, it will either be 5, 3, negative 5, 3, negative 3, negative 5, and this one would be the 3, negative 5. So my diagram was somewhat accurate. Okay, kind of on the right track. Okay, hope that helps. Good luck. Have fun. I'll catch you guys later. Okay, bye-bye.